Yeah, I'm very glad to be here. Thank you for the invitation. And I really like the city. I had a chance to walk around it yesterday. Um, yeah, and let's start. So this presentation will be about my experiences. It's not like a story. It's more like a gathering of some experiences, lessons learned. So yeah, the things that I wish I knew like 8 years ago. Yeah, I hope it will. You probably know some of that, and I hope you will learn something new. Okay, first things first. I'm Michał. Nice to meet you. I'm a software developer for like 15 years, and as I remember, I always worked with medium or large systems. The ones that takes time to get to know. And I worked mostly in Azure in C#.NET. So yeah, if you want to reach me, try on LinkedIn. I live in Poznań, Poland, which is like in the middle of Warsaw and Berlin. And last 6 years, I worked for UK companies remotely. It's a nice experience. Okay. Right. I will be talking about a domain that I worked for like last 5-6 years. So the domain is hospitality, basically. Not this one, this one. Company is called Guestline. It has like 3,000 hotels across the world, mostly in Europe and UK, but there are like 200 in Germany. So I actually work on that part some time ago. Anybody implemented Zugfahrt, which is like e-invoicing for Germany? Okay. And yeah, I'll try to tell some stories around that. So it was a big monolithic system developed for a product company for 20 years. So you can imagine that there are developers coming and going, all those thoughts and concepts are there. Not really brought to the finalization. So a lot to work on. So I like this definition of legacy software, that it's too scary to update and too profitable to delete. It's a workhorse of your company. You cannot get just rid of it. It makes money. And it actually is pretty good, basically. I think that most of the systems are, that vital systems are just legacy. They're big and legacy. You have to deal with it. Okay. So let's start with the learnings. I know that developers don't particularly like to write tests, but I liked the talk yesterday with the property testing and the invariants. And it's so true that the only certain things are tests. So if you need to have a deployment on a Friday afternoon, and do you feel good about it? I wouldn't. But if I have tests in place that tests at least the success path, I know that nothing very terrible will happen. I think that should be a requirement, right, to write tests. But is it easy? It's not. I remember first months working in Guestline was like I was implementing a feature for 1 day, and I was writing tests for 4 days. Why? Because the code was untestable. You would have to do like refactoring to make it testable. And that created more bugs, actually. So what can we do? Oh, another story. Harry Potter, I guess you know that. It's a series of 7 books about a young magician. You know that it's 1 million words in all those 7 books, 100,000 lines, and it's a story, like a system, IT system. So who is working on a computer system that is larger than 100 lines, 100,000 lines? Okay, most of the audience, thank you. And let's say the product owner comes to you, and it's yeah, it's something that's like similar to the life. He comes to you and he says, you know, we have this great deal. The chain of hotels wants to give us like 3 million euros. It's like a cost of our department for the next 1.5 years. And we almost have it, the feature they want. So you start asking, what is the feature? And he says, we almost have it, we just sold it, so just take your time, take a half a year, and it will be a great opportunity. So we try to ask and try to develop the feature. It's quite a big feature. Let's say, you know, the Hagrid, it's a half giant, works as a teacher in Hogwarts. And the product owner says, okay, this company wants to have it as a donkey. Would it break anything? How long would it take you? We don't know. But would it break anything? How could you be sure? You can only be sure having a good test that tests your other functionalities while you work on a bigger thing. And you started to wonder, okay, so he needs to talk, but it's a fantasy book, so he can talk as a donkey, like in the Shrek movie. But would he be able to fly a flying motorcycle, as a Hagrid did? Because he don't have hands, right? So there are some things around you have to take into consideration, but the test will save you. And the more granular ones you can write, the better. So start with unit tests. If that's not possible, service tests. If that's not possible, UI tests. And that was the thing we started with Guestline. The acceptance tests that took, because it's a HTTP application, basically a web page, we started with having a URL and developed tests that treat it as a black box and test the success scenarios. So it's an idea to test untestable code, like with the God classes. Acceptance tests, those the high UI level ones. We wrote it with BDD approach, behavior-driven development. The sort of tests that are written in natural language. So you would be able to easily read those steps. And here's the example. We use this spec flow. So it's an example of creating a reservation with, you're a hotel manager. Client comes to you, want to see what's your availability. You look at the planner, which is a sort of a calendar. You click on an empty spot, create a reservation, fill in the customer details, and it's done. What's cool about it is that you can reuse those steps to test other scenarios. And inside, it's actually code that I understand, the C#.NET. And every step is just an attribute over the method. And the methods goes like, fill in the nights that would search for an HTTP tag with an ID, and just fill it in. So nice and easy. Yeah. And it does fail from time to time, but when it does fail, you know that you probably shouldn't ship it to production. It may cause problems. And by default, it's a Azure DevOps pipeline of deployments, and it stops when it's green. It's red. Wouldn't let you to deploy. Yeah. Okay. The God classes, the big tangle of wires, or big ball of mud, if you can say that as a legacy software. Where would you start? Let's say you have this let's say you have a year. You need to develop a feature that can be done in 2 months. How you use those 10 months? Where do you start? You want to make things better. Start from the easiest place. Where is that? Let's think. Let's say that this is our monolith system. So it has some front end on the top. It has this tangle of wires in the middle. And down below it calls some APIs and uses database. So the simplest thing we can do is take one wire, just stick it on the side. You know how great it looks? A single line there. So I learned that fetching data is much easier than updating data. So instantly you can divide those two cases, and you can have commands and queries, like fetching and updating data. So that's a nice concept that you can have. You don't have to use all the layers, all the adapters, interfaces. You can just fetch the data. And your code base, it's a bit easier to read and a bit smaller. I mean, for the God classes. The other part, if you have those front-end classes and middle one and the lower one thing, let's think about how the classes interact with each other, how many dependencies are incoming and outgoing. So if you look at the front end, it's usually one HTTP call that calls, let's say, 5 classes. In the middle, that's a tangle of wires. A lot of classes call me, I call a lot of classes, or dependencies. And in the lower part, you usually get calls a lot, but you call like a database or an API. So judging by those dependencies, what do you think? Where would be the easiest part to start? And it will be either from the top or from the bottom. So querying data would actually be at the bottom. We don't need to go through all of those complexity. Let's just have a call here. Starting from the top, that would be a micro frontends. I'm not really a front-end guy, but I really wanted to mention the micro frontends because it made a huge difference for us. Okay. Right. The micro frontend is an application that has really small UI, some backend and some client code on the front end, and some backend code that does calculations, provides data, and saves data. So it can have a storage as well. So look at those wires. These are pretty nice done. You can. It has a separate repository, separate deployment pipeline. So it's all nice. In here, we use old technologies like web forms, which is really 2000 technology. And in here, we can use React, Vue, Node, anything we want. And it's much easier to work with. So how can we, maybe let's switch. So we used at Ready Technology open components. We haven't written it ourselves. We just used it. So as I said, separate deployments, new UI, those components can be reused. And it's great for experimenting. I will show an example in a minute. This is like a most frequently used page in our application. It's a view of the reservation. It tells you a lot. It has a lot of data, a lot of options. Maybe not so beautiful, but clients love it. So here are the open components. So those parts are not really in old technology. They are written in different technologies, like one could be Vue, one could be React. And they have different repository than the main page and different technology stack. They even are developed by separate teams. And now you can have multiple teams, multiple developers working on the same page on a different repositories and make things happen faster, actually. Less problems with merges, less problems with deployments. Yeah. The technology behind it is rather simple. Check it out, open components. The only thing you need in the code is a script that runs on a page, and it will replace the OC component HTML tag with the content from repository of OC components. And it's done. Okay. But you need to somehow communicate with the main page. So doesn't matter how you do it. If you pass in the query parameters, if you use JavaScript events, as long as it works, I would do events because it's a better integration pattern than the others. Yeah. That's an example of an OC that we built like in 2 weeks. If you have a hotel, you book 2 rooms, you want to have all the charges on your 1 room, so you can issue the invoice. So there is an option to just move the charges from 1 room to the other. It's actually a drop-down. You pick the charges, you enter the drop-down, just enter the room you want to move to. On the left side is old one, on the right side is OC component that we only switched the drop-down part. And we just switched it for users. But see what we did? On the left side, you cannot really search. If you have 300 rooms, you would need to scroll a lot. On the right side, we added an option to search. You can type in something, but we haven't told the users. It's simple enough. And without any training, they just started to use it. And they started search. So in blue, there are people that just searched, that just scrolled. And here, they started to search. So let's say 2/5 of the people already knew how to use it. And yeah, it's just a newer design written in React. Took 2 weeks. Okay, and as a side note, it's application sites logging, and I think enabling developers to write logs to use feature toggles is like the most fundamental thing in legacy software development, because you reach the data, you know how people use it, and it changes a lot of stuff. Okay, next learning wouldn't be a pleasant one. It's asynchronous systems are not synchronous. You may think it's it's true, but how does it work and how affected us? So synchronous application would be like, I have a request. Let's say I'm adding a deposit. I took a payment from the user, I add a deposit, I process it in my system, and it appears as a balance on the reservation. So green arrow goes to the system, red arrow goes back. In the meantime, we show the user a spinner. So when the user sees a spinner, he have to wait. System does something. And if you have microservices, there is a chain of requests going in and going back. If everything's correct, you can present the answer to the user. And if something goes wrong, you can go back anyway and present some red label. It's wrong. Something went wrong. Try again. But if you switch that to messages, which we should because it's better approach, yeah, you consume messages on your own pace. It's better for deployment. But how do we get the user to actually get an answer? We couldn't show a spinner and do polling, but polling is not ideal. You don't want a user making a payment. The client would ask you every, 5 seconds, is it done? And we do like, 50,000 payments a day, and you keep asking. That's a lot of traffic. Do we need that? Not really. So we thought we didn't have this problem with a synchronous application. Something went wrong. And so how do we present an answer to the user? Are we there yet? So we used a Signal R, which is a Microsoft technology, but we can use it outside of .NET Word and Microsoft Word. So it's a technology that uses different transmission protocols like WebSockets. And it creates like a private chat between one piece of code, let's say in a client application JavaScript, and a server on somewhere on a microservice. And you can have a chat. So when you start processing, the client, JavaScript client tells you, yeah, let's start a chat. I just sent you a deposit. Let me know when you process it. You send its ID, started a chat, and when a service processes it, it uses the same ID that he processed the payment, enters the chat and says, hey, everything's done. You can refresh the page. Goes back to the JavaScript client, and it refreshes the page for the user, showing the correct balance. So it's a magical technology. Yeah, all kind of languages you can use that. And yeah, we are using that in production. Oh, it's in Polish anyway. But the thing is that with messages processing, you cannot always know when something goes wrong. When it does go wrong, and I'll show you in a minute. But it's eventual consistency, right? You will get an answer, you will process the message, but you just don't know why. And you need to actually rethink a bit a UI. Let's say in the synchronous application, I'm rewriting a report generation. I click enter, and I wait for the report. Let's say I need to wait a bit more time, like 20 seconds. But it's spinning. It's okay. With an asynchronous application, you need to rethink what to do. Maybe you should say, okay, we got your request for the report. Just we will send you an email with when it's ready. You need to rethink not only how you code it, but also how you communicate to the user to have more sense. And it wasn't so obvious what to choose. The next thing, microservices, is not always the way. Back in the day, we created a pipeline that you would just have a simple form, fill in service name, repository name, the technologies you need, and within one click and like 60 seconds, the new service would appear for you with the links to the repository, links to the pipeline, and it was so easy to create new microservice. We end up having like 150 microservices, and it was way too much, like way too much. Mistake, but okay. Again, deposit processing. So we have a monolith here. We are adding a deposit for the user. Then it goes to events. So we process events. Deposit service catches an event and processes the deposit, puts it in his own database, and also communicates back to the monolith. Monolith saves it on this database. We had a lot of work around deposits, like retaining a deposit, changing the payment method, a lot of new functionalities. So we thought, let's write a microservice. It's so obvious. We have our own micro frontends. We have the service that knows all the knowledge, what to do and how to handle that. Perfect. But let's see what happened. So when something goes wrong, and the message doesn't come back to the monolith, it's not correct, because we have, let's say, deposit here or somewhere in the pipeline, but not there. And it's a problem, because client paid you €80 for a stay in your hotel, and something went wrong, you don't know what, and you don't have this money. You actually don't know where it is. So the client is waiting, you don't know what to do. It's a problem. It's a problem that we get a call to the support. You need to fix this. Where's the money? Client wants to know. And it's a huge problem. The problem with events is that something always fails, and you need to take it into consideration. For us, we didn't know what happened with the deposit, and therefore we need to create a report at the end of the day. And it has to be correct. If it's not correct, the taxes are not correct, you can get a fine in Germany, actually. Yeah, a city tax. Do you know that Hamburg and Hanover are the two cities that have like a specific city tax? We had to like specifically implement a city tax for Hamburg because they figure it out themselves what to do and what would be the tax. And it has to be correct, and then you have to create like a report for the authorities. Yeah. But it has to be correct. If something is not correct, you can get a fine. And that's a huge problem for German hotels. And processing financial data across multiple services is not ideal, actually. Because something goes wrong. Even if we process 20,000 deposits every day, the 5 deposits on average would go, some days misconfigured, and you have a problem. You have 5 calls to the support, and they don't trust our software. So that's a problem. Even though it's almost good, it's this kind of a bug percentage. You cannot accept it with finances. So what we would do, we would just remove the storage, base the storage there. And once it's done, we thought, yeah, okay. So we have a separate deployment here. We have a separate repository. It's all good, but why do we have this communication here? It always can be a flaw. So we have some then transient errors. It's still something you need to fix. So what do you think about this thing? It's actually a module. It's a separate module. You can have like an internal events or internal API that it's not called directly, but it's much simpler, actually. It was a problem with bounded context wasn't well divided. It was the start of it. But in the end, maybe it's not worth it to make a microservice. Not in every case. Feature toggles. Okay, what's the time? Good. I thought, I said already that feature toggles are like a base thing that you need to have because it's so easy. You just flip the switch, you develop the code and ship it to production without really working. And you can test it based, switch it for a beta site or beta client. And you're not worried. It works. I mean, the code doesn't get executed, so it's safe. So I've implemented my own feature mechanism. Have anyone implemented a feature mechanism? Okay, yes, some of you, I'm impressed. And it's not always ideal. I mean, for me, it could be always better. So we used a third-party software, and it changes a lot of. It was just easier to use because the config cut is something that you pay not a lot of money, but it has a nice UI, so it's available for the product team, for the third line. Something goes wrong, then go inside, flip the switch, fix the problem for a hotel. And it has a lot of conditions you can based on. You can based on account ID or client ID. And it comes with ready clients, like in a JavaScript client, C# client, I believe Java as well. So really nice to use. Yeah, and for now we introduce a feature for almost every code we write. If it's only possible to use a feature, it's much safer to go with the feature to production. If it's only possible, no. So what you normally do in a code, I hope you see it. You have this code that runs, and you want to introduce a feature. It's just an if, right? It's an if. So inside an if, it's a new code. On else, it's an old code. And basically, when everyone gets the feature rolled out to set to true, you just remove the old code, and the new code stays, right? And it's all good. How you can make it better? So let's say we wrap the old code into a dependency, a iService implementation. And okay, it creates some complexity, some dependency, but it also gives advantages. Inside do something, we would have like the same interface for old code and new code. We might have unused parameters for some of them, but okay, we can refactor that later. The same interface for old implementation and new implementation. Therefore, the original class doesn't need to know which code it's using. And of course, we need some kind of a if statement, right? So we build a factory that creates a correct implementation of our service. And the fun thing is that we use, it's just an if. But let's move this if into di. So instead of writing a separate class, we move an if to the di. So we fetch the config cut, we check if it's enabled, and then only if it's enabled, we fetch from a container the implementation we need. It's less code and less dependencies created. And the fun thing about it is that when you roll out the feature to everyone and you just need to remove the code, you just remove this part in the DI, the old implementation, and this class is not affected any. And it doesn't know actually that something happened. It's not affected. And if you look at it, you have this abstraction layer, which is our interface. So at the beginning, every code uses old implementation, float supplier. I just took the image from somewhere, but it's the branch by extraction pattern. And slowly you switch client by client to use the new supplier, and in the end, everyone uses a new supplier. But the client code doesn't know about it. And the last thing, logging, with the feature toggles, what if you, when you use the feature toggle, what if you can log it? I mean, every time you have a log that someone uses your feature, you have a log. With this information and something goes wrong, you can know if that was caused with the feature toggle enabled or disabled. If you have 3,000 clients and you, I don't know, do A/B testing, you don't always know what is the state of a feature in this particular second and for this request. It would be really nice to know that. So instead of just checking the feature, you can just check and log. And in .NET, it supports OpenTelemetry, and you have this activity object that just adds a property to whatever log you create. It just adds a property with the value of the feature. You can set it like that. So what you end up with, I'm not sure if you use Azure or Application Insights, but here is what you see if you dig into like a single user request. You see all the history, what was done with every service, every database. Of course, depends on your logging level, but you can see what happened and what time it took. But also, if something fails or it doesn't, you have those properties like a client ID, reservation number, and the state of the feature. And you can do later like a, not a chart, a workbook You can list all your features, list all your errors, and see where if errors was caused by a recently enabled feature. Strangler fig pattern, that was mentioned, so I won't take a lot of time on that. You basically have a monolith and you care about your leaves, like clients. You always want there to be green. You always want it to look wonderful. You don't care what's below that. And you start to build your new code with features, with DI, in a way that clients don't see it. The hardest part of creating new features or just refactoring the code is that client don't see it. It works as it used to be, but it's just better underneath. And it's a lot of thinking in that. And I think that's the one of the last slides. Try the impossible. So, do you write a software that generates PDFs? Okay, some of you generate PDFs. We have this PDF generator that comes with the old library, but back in the days, like 15 years ago, we built this reports. Every customer have a different report set up. If we were to change the library of PDF generation, we would need to redo all the reports for every client. It's impossible to do. So what we thought, it's using the old framework. We want to have it like decoupled from the rest of the application, let's say, preparing the data for reports. It takes a lot of code as well. But we want to get rid of this PDF generation. And we thought, it's impossible. It's impossible. So what we did, short meme, you have this mindset of a legacy software developer. It's too hard. I mean, why would you try that? It's all good. So what we did? A hackathon. Not sure. Do you like hackathons? I sometimes like them, but with the legacy thing, can you do a lot in a hackathon? Let's say 2-day hackathon. Not really. So let's say we want to refactor this PDF generation. We want to extract it to the separate library. Would it work after 2 days? The 15 years of neglecting this part of the code? Can you fix it in 2 days? No. Would it work? It could work in like a small specific case when you mock a lot of dependencies and comment out a lot of code. It could work. And after 2 days of working, you have a code that has no chances going to production. So what's the value if it's just working for one case? The value is that you have this commented code, and you already did the analysis. What needs to be done in order to get this PDF generation out? So you have all those lists of smaller tasks to be done first in order to attempt the bigger one. And that's the true value. Not the code that you will just throw away, but the list of things to do. And I did that approach, and for a half a year, I wrote a small PRs week after week. And as of a... sorry, I'm missing some words. But after a half a year, it was possible to do a bigger thing, like to decouple the PDF generation. Not for every case, but in 80% of cases. So we are on a good path. We know that. And it's not impossible. It's hard. And this is the idea how you can get a glimpse of how to do it. So try the impossible. And what's not ideal, you need to accept the intermediate state. So that something is not ideal, that something is not yet ready. You don't want to ship that code. but you have to. It's the intermediate state. Just keep on working on it. As a small example, let's say you have a status on the reservation that it's edited like, I don't know, 50 times. Not only in a reservation class, let's say it's edited in 10 different classes. So you see the problem there. Anybody can enter my object and set the status to whatever he likes with whatever scenario, and I don't know about it. So let's create, for the occurrences that status changes, let's create a method, set status. And you try to figure out what properties actually are changes together, and you try to conceal your properties, your updates of your properties inside. And you need to accept that you're not going to change the whole system, but you can start with the smaller steps, and after some time, it makes the system easier. So stay calm, keep refactoring, and I wish you all the best. Thank you.
Thank you so much. Just in time, Michał.
Really?
Very good. So we could have short questions with 2 sentences answers. If you like to have, if you have any comment or any spontaneous questions. Doesn't look like that. So, one.
Okay.
Thank you for the great talk. Did introducing the open components for the UI increase the test complexity? Considering you want to test the whole UI and not just the component in the integration testing, was it difficult, more difficult to do after that?
So actually, introducing open components made the testing a bit easier, because if we moved the untestable web components, it was web forms, ASP.NET web forms. We moved it to React, and we added a separate repository, React project, with some JavaScript library that would test your HTML output for just this open component. So that was easier to test on how the UI react to user inputs. So in this case, it was easier. And for the acceptance test, where you have this black box and you click all over the place, it didn't make a big change, because it's just the UI that changes. Yeah. I hope I answered your question. Thank you.
Okay, great, thank you. Perfect. So then, thanks a lot, Michał. Then we have a short break. Oh no, 15 minutes break, and at 12 o'clock we're going to talk about in English talk again about exceptions, getting them out of the code base. So see you in 15 minutes.